In this question, a figure is given of a single line diagram of a 4-bus power network. Branches B1, B2, B3 and B4 have the impedance of 4Z, Z, 2Z and 4Z PU, where Z is the R plus JX. The current drawn from each load bus mark, it is a I. It is equivalent to the IPU. If the network is to be operated with the minimum losses, the branches that should be opened is which branch we have to open so that the losses will be minimum. So we know that the losses occurs only due to the resistive value. So B1 impedance is a 4Z, so its resistance is a 4R because R is the only responsible for the losses. And for the B2, it is become R. B3, it is a 2R because Z is equivalent to R plus Jx, and for B4 it is a 4R. 4R, R, 2R and R. So what is given here? The B1 impedance of B1 is given. That is a 4R means 4R plus Jx. Impedance of B2 is Z means R plus Jx. Impedance of B3 2R plus Jx. Impedance of B4 4R plus Jx. The current is equivalent to I. So let us check one by one if B1 branch is removed. Suppose if B1 branch is removed, first case, if we remove the V1 branch, then our system is become like this. B1 branch is not there. Current is equivalent to I. It's a I and I. So if we apply the Kirchhoff current law, the current here will be I only. Current in this branch will become I plus I means the 2I, and the current in this branch is become 2I plus I means the 3I. The resistance of these branch are the R, 2R and 4R. It's a R, 2R and the 4R. 2R and 4R. Now the total losses in power system will be 3I square into R, 3I square into R plus 2I square into 4R plus I square into 2R. 9I square into R, 16I square into R plus 2I square into R. So the total P is the 27I square into R. Now in the second case, if the B2 branch is removed, if B2 is removed, a B2 branch is removed. So when B2 branch is removed, The system will be reduced in this form. B2 branch is not there. Current is the I. Current is I. Current here is I. So if I apply the Kirchhoff current law, the current in this branch will be I. In this branch is become I plus I, and it means 2I. And this branch is become 2I plus I, 3I. And the value of resistance is a 4R, 2R, 4R. So the total power loss in system. If B2 branch is removed, then the total power loss in the system will become P equivalent to 3I square into 4R, 3I square into 4R plus 2I square into 2R plus I square into 4R. So 36I square R 8I square R plus 4I square R. It's a 48I square into R. Now, if the B3 branch is removed, if B3 branch is removed, now we are removing the B3 branch. This is the B3 branch. So B3 branch is removed. System is reduced in this form. This branch we have removed. Current is I. Current here is I. Current here is I. Now, apply the Kirchhoff current law here. Here the current in this branch will be I. And current in this branch is become I plus I 2I. This current is I. Now, it's a 4R, R, 2R and the 4R. So the power loss in the system. The total power loss in system. The total power loss is become I square into 4R 2I square into R I square into 4R. So it's a 4I square R 4I square R plus 4I square R. Total power loss is become 12I square R. Now if B4 branch is removed, is removed. B1, B2, B3. This branch is removed. Now current is I. If we apply the Kirchhoff current law, current in this branch is become I. Current in this branch is become 2I. Here the current is I. Now the resistance of the branch is a R, 2R, 4R. So the total power loss in the system in system. P equivalent to 2I square into R, I square 4R, I square 2R. So 4I square R, 4I square R and 2I square R, 9I square R. Sorry, that was the 4R, na? 4R. Two R. So this will be 2I square into 4R, I square 2R, I square 2R, 16I square R plus 2I square R plus 2I square R. This is only R. So total is the 19I square R. So the minimum power loss occur, that is the 12I square R, when we remove the B3 branch. Clear? So minimum power loss occur. If branch B3 is removed, branch B3 is removed. B3. So C is the right option.